Okay, so this is the L'Hopital's rule, and it's basically another method of evaluating limits that result in an indeterminate form. So let's say we have the limit as x approaches a in f of x over g of x. If this limit results in 0 over 0 or plus minus infinity over infinity, you can say that limit as x approaches a in f prime of x over g prime of x will give an actual answer you can work with instead of an indeterminate form. And f prime of x basically means the derivative. So this is the limit as x approaches a in the derivative of f of x divided by the derivative of g of x. Okay, so number one, we have the limit as x approaches infinity in the function ln x over x. So if we just use direct substitution here, and we plug in infinity, we'll end up having ln infinity over infinity, which just turns out to become infinity over infinity. So this is an indeterminate form, so we need to use a rule. So first, the derivative of ln x is just going to be 1 over x. And the derivative of x is just going to be 1. So this is just going to be 1 over x divided by 1, because we can say this is f of x and this is g of x. So limit as x approaches infinity in 1 over x divided by 1. We can just ignore this 1 because dividing by 1 is the same thing as the function. So now if we use direct substitution, we'll have 1 over infinity. Now this may look wrong, but when you're finding the limit of something and in the denominator it's infinity, this is going to be equal to 0. Because when you divide by such a large number, it's going to approximate to equal 0. And just remember, this is the limit, not the actual function. So when you find the limit of it, the answer is going to be 0. So we can box this in. Okay, number 2, we have the limit as x approaches 0 in the function e to the 3x minus 1 divided by x. So let's try direct substitution again, and let's see what we get. So e to the power 3 times 0 is just going to be e to the 0. And anything to the power of 0 is going to be just 1. So we're going to have 1 minus 1 divided by, and this is just 0. So 1 minus 1 is 0. So this turns out to be 0 over 0. So now we need to use the L'Hopital's rule. So the derivative of e to the 3x minus 1. So first, let's just write d over dx. Okay, so the derivative of this function is just going to be 3e to the 3x. Because if you remember, the derivative of e to the x is just e to the x. And since this is inside the inner function, the derivative of 3x is just 3. That's why we multiply. And this is, you also have to know the chain rule a little bit. And then the derivative of x is just going to be 1. So it's just going to equal 1. So now f prime of x over g prime of x. So now we can just say the limit as x approaches 0. And since this is divided by 1, we don't have to include it. And 3e to the 3x. Now if we use direct substitution, this is going to be e to the 0. So 3 times 1. So 3 times 1, the final answer is just 3. And let's box this in. Okay, number 3, we have the limit as x approaches 0 in the function square root 1 plus x minus 1 divided by x. So if we use direct substitution, we're going to get, if we have 1 plus 0, it's just going to be 1 minus 1 over 0, which is just going to turn out to be 0 over 0. So now let's use this rule again. So the derivative of 1 plus square root x minus 1, or square root 1 plus x minus 1, is just going to be 1 over 2 square root 1 plus x. And the derivative of negative 1 is just 0 because it's a constant. And now the derivative of x is just 1. So we can just ignore because anything divided by 1 is the same thing. So now let's use the rule. So the limit as x approaches 0 in 1 over 2 times 1 plus x square root. Now if we use direct substitution, we're just going to end up with 1 over 2 because the square root of 1 is just 1 and then 1 over 2. And this is the final answer. Okay, so in number 4 we have the limit as x approaches 0 in the function 2 tan x over 5x. So if we use direct substitution, when you plug in tan 0, that's just going to be 0. So 2 times 0 is just 0. And then 5 times 0 is also just 0. So now we need to use this rule again. So the derivative of 2 tan x is going to be 2 secant squared x. And now the derivative of 5x is going to be just 5. Okay, so now we have our new function. So limit as x approaches 0 in 2 secant squared x over 5. And if we plug in 0, so secant x, or when you plug in 0, secant 0 is just going to be 1. And then, so 2 times 1 is just going to be 2. And then 5 is just 5. So the answer is just 5.